So in lesson 9.4, we're going to use our square root property, or just being able to solve an equation with square roots, in order to get the solutions for x in our quadratic equations. So we're going to look at three different formats. The first one is just when x squared equals some number. And let's just do some examples of these, and then we'll put together a conjecture on, how our solution will work if it's two solutions, one solution, or no solutions. So let's say we have just x squared equals 49. Well, to solve this, we do the square root of each side, and this undoes our square root. Square root of 49 is 7. Now, we can also have -7, so we need to include that it's a plus or minus 7 in our answer. This part is very important. If we don't do that, then we're technically only showing that there's one solution, and there's not. There's two. X can be positive or -7. What about when our A value in our standard form of the quadratic is not 1? So what if it's something else? So we'd have a format like this. Let's say we have 7x squared equals 112. So we would solve this as normal. We need to separate our coefficient from our exponent, and so we're going to divide both sides by 7. There's nothing else to do. That gives us 16 on this side. Then we take the square root of each side, and we get positive or -4. So x can be positive or -4. Let's try one more of those. We'll squeeze it in here. -3x squared equals -24. So it's okay if we have a negative as long as we don't end up with one. So let's see how this works out. So we're going to divide both sides by -3. And now we can see that this changes to a positive 8. And then we take the square root of both sides. Yes, we'll see that. We get x is equal to positive or negative square root of 8. Now we could use our simplifying or rewriting radicals unit or lesson from last time. We can actually write this, right, as the square root of 2 times 4. 4 is a perfect square. So this answer could also be positive or -2, because we pull this out, take the square root of 4, it's 2. 2 times root 2, or 2 times radicand 2, or 2 times the square root of 2, however you want to say it, but those are all the different ways. Okay, what if we have, so this looks a lot more like standard form, but we have an A value that's not 1, and then we have a B value, and then it equals something. So let's look at a problem like that. So let's say 3x squared minus 5 equals 22. So obvious first step, we need to add 5 to both sides. 3x squared equals 27. We divide both sides by 3. X squared equals 9, and the square root of each gives us positive or -3. So in each of these cases, we had two solutions. We could have the positive or negative of the values that we got. Let's see something where we may not have two solutions. The That would be when x equals 0. So we have something like x squared. So when when our output equals 0, the only option would be to take the square root, which means x would equal 0, and there's only one solution because you can't have a positive and a negative 0. So anytime you're solving, and even if you have to, let's say you have this, whoops, this is C. Once you subtract b and then divide whatever it is, once you get down to x squared equals 0, the only possible solution is that x is 0. So that's one solution. Okay. Let's do something like this. So we need a number squared that gives us negative 16. Logically thinking, that's not possible, right? And we cannot, you can try, we know this would be 4, but if 4 squared is positive 16, negative 4 squared is positive 16. So in this case, this is no solution. So typically when you have it down to, you've isolated it just to the x squared, and if it equals a negative number, it's just not going to be possible. So in this case, it would be no solution. Okay, one more thing, and then you guys will practice. I'm going to sketch this. It is not perfect, but looking at this, we can see this is a right triangle. And if you recall I don't know why I wrote that. Oh, I didn't write that. Pythagorean Theorem, a squared plus b squared equals c squared, allows us to find a missing side length in any right triangle based on this formula. So let's say that we're dealing with, I don't know, a cell phone tower. And the only thing we know is the height is x, and the base of this distance is x. So we know that the wire that goes diagonally is 200 feet, okay? Remember that Pythagorean theorem has us squaring, so literally making squares off of the sides A, B, and C, which is going to go way out here. Again, not perfect, but when we square these two are equal to the hypotenuse, or that diagonal side. So we know then that if we look here, x squared plus x squared is going to be equal to 200 squared, right? So now we've got a problem where we can use the square root feature or property to solve for this. So we'd be taking the square root of each side. Actually, before we do that, we can combine them. Let's do it that way. So if we evaluate this, $200 squared gives us 40,000, and this is 2x squared, right? So now it's looking like that ax squared equals c format. So then divide both sides by 2. Just going to erase this. Solving like we normally would. We get x squared equals 20,000. Now we're going to take the square root And we're going to write this out because we want to get the closest approximate value. 20,000 is not a perfect square. So hold on one second. Okay, computer shut off. So we want to use what we did in the last lesson, 9.3, to simplify this expression with the radical. So this can actually be 2 times, what is it, 100 times 100? Okay, because that's 10,000 times 2 is 20,000. So then we can factor one of these hundreds out. So we get the positive or negative, remember to include those, 100 times the square root of 2. This gives us a more accurate answer than just saying square root of 20,000. Or, I mean, this makes a bit more sense. So you can see that this number is really close to 100. And if we put that in the calculator, we get a number that's about 141. And so that's it. That's how we can use it to solve real world problems as well. So you're going to practice now on just solving different equations. Identify if it's one solution, 2 solutions, most of the time it will be, or if it's no solution because it's not possible.